Hi guys, I'm going to go back and redo, or I guess do for the first time, example number 3, A and B. Since we didn't get to it today, I'm going to go ahead and record it for you and put it on my website. Hopefully it helps. Okay? Example number 3A says we're wanting to find the volume of a solid formed by revolving the regions bounded by the graphs of y equals x squared plus 1. So that's a parabola opening up starting at 1. Y equals 0, so that's really the x-axis. X equals 0. So really the y-axis, and the line x equals 1. And so on this one, they give you a picture. Again, they're not always going to give you a picture, though. So if you aren't given a picture, I suggest on your test you are required to draw me a picture, a sketch of the graph, so you kind of can see what it looks like. I'm going to do it both ways so we can kind of compare. Is disk easier or is shell easier? Okay. On your test, I'm not going to specify which one you have to use, so you're allowed to use whatever one you like. Sometimes, though, one is easier than the other. Sometimes one is almost impossible, so you have to do the other one. Let's look at the disk method first. If I'm revolving it around the y-axis, my axis of symmetry is vertical. If I'm doing the disk method and my axis of symmetry is vertical, which way do my disks lie? Well, they lie perpendicular, so they're horizontal now. So if I'm doing it with the disk method, I'm doing it with respect to y. So if I'm doing it with respect to y, all of my equations need to be x equals equations. So I would have to resolve this original equation to x equals the square root of y minus 1. Sorry, I was looking at the wrong problem. Square root of y minus 1. Okay? If I'm doing it with respect to y, if you look from 0 to 1 on the y, if I were to be rotating that about the y-axis, there wouldn't be a hole in my solid, right? If I'm looking at just this little piece, there wouldn't be a hole in my solid. It would be a cylinder without a hole. And so I would be using the disk method from 0 to 1. But if I'm looking from 1 to 2, isn't there going to be a hole now in my solid? So from 1 to 2 on the y, I would be using the washer method. So I actually have to set up two different integrals on this one. I've got to set up an integral from 0 to 1 on the y, and I've got to set up an integral from 1 to 2 on the y, and do what with those two integrals? Right? Add them together, right? Because I want to find the volume of both of them and add them together to get a total volume. Okay? When I revolve it, my my figure is going to be a disk. So I need to do my pi r squared. If there is no hole, so from 0 to 1, since there's no hole, I just want to do my pi r squared h. Okay? Remember, my disks are laying sideways or horizontal, so I'm doing it with respect to y. I need to figure out what the radius of my disk is from 0 to 1. And isn't it always going to be the same no matter where I draw it? My disk is going to be the same, my radius of my disk is going to be the same. And how long is it? 1, right? So pi r squared would be pi 1 squared from 0 to 1 only. Okay? Now let's look at from 1 to 2. From 1 to 2 on the y. If I'm just looking from 1 to 2 on the y, because I'm going to have a hole, I need to do big R squared minus small r squared. Okay? Still with respect to y, because my rectangles are going horizontal. If I want the big radius, I need to go from my axis of revolution all the way to the outside of my solid. Okay? My axis of revolution all the way out to my solid. And isn't that going to be the same distance all the time? So my big radius is going to be 1 still. But now because there's going to be a hole, I've got to subtract out my little radius. My little radius is what's going to cause that hole. So I need to go from my axis of revolution to the inside. Well, my axis of revolution to the inside is going to vary depending on where I put my rectangle, but it's always going to correspond to my function. Well, remember, because I'm sideways, my function isn't going to be a y equals anymore. It's going to be my x equals function, my square root of y minus 1 squared. That's my big radius minus my small radius. Okay? You should be able to integrate both of those parts. Now you have two different integrals, so you're going to have to do both of them separately. Then you're going to have to add them together. It's kind of complicated, right? But you can still do it. When you do the disk method, you should get 3 pi over 2 as your final answer. Okay? What if I do the shell method though? So let's go back over here to the right and let's look at the shell method. I have the same exact graph. I'm still rotating it around the y-axis, but now because my axis of revolution is vertical, if I'm doing shell method, which way do my rectangles lie? Well, they should be parallel, so they're also going to lie vertical now. Okay, so now my rectangles are going to be here. And I don't have to worry about separating it into two different integrals because I can do it the whole way, okay, because the way my rectangles are lying now. Now, because they're lying vertically, I'm doing it with respect to who? I'm integrating with respect to who? With x, right? Shell method is the 2 pi p h w. So I have my 2 pi. I need to figure out my limits of integration because my rectangles are lying vertically. I'm doing it with respect to x, so from where to where? On the x. 0 to 1, right? Now I need to find my p. P is the distance from your axis of revolution to wherever your rectangle is. The distance from your axis of revolution to wherever your rectangle is. So what is that distance? If I'm going from my y-axis over, isn't it just the value x? Okay, that takes care of my 2 pi, my p. I need to do h. H is the height of my rectangle. Now again, my rectangles are vertical, up and down. So I need to figure out what it is, the distance from here to here, the top to the bottom of my rectangle. If I go from the x-axis up, doesn't that always correspond to my function? But x equals or y equals function? Right? Because I'm doing it with respect to x, it's going to be my y equals function. Y equals my x squared plus 1. My w is the widths of all my rectangles, or my dx. Okay? That would be my setup. This is a little bit easier to integrate, right? There's only one integral. I can distribute that x through, integrate in parts. So shell method on this one might be a little bit easier, might be a little bit faster. When you integrate it, you should get the same answer. You're still finding the same volume of the same solid. So it should get the same answer, 3 pi over 2. So no matter if you do the disk or the shell method, you get the same answer. One just might be easier than the other. You might prefer one over the other. Okay? Let's do example 3b. Example 3b says a pontoon is to be made in the shape shown. The pontoon is designed by rotating the graph of y equals 1 minus x squared over 16 from -4 to 4 on the x about the x-axis. So then they even give you a graph over there of what it looks like, where x and y are measured in feet. Can you find the volume of the pontoon? Okay. If I do it the disk method, we are revolving it around the x-axis. This is my axis of revolution. If I'm doing the disk method, which way do my rectangles lie? They lie perpendicular to my axis of revolution, so up and down, right? And when I rotate them, they would be little circles. They would be little disks. Okay, so I need to do my pi r squared h. Now my circles, my disks aren't going to have any holes in them, so I just need to do my radius squared. Okay, because my rectangles lie vertically, I'm integrating with respect to x. Okay, and now I just need to figure out what my radius is. Well, I actually need limits also, right? I need limits and I need a radius. What are my limits here on the x? Well, didn't it say up in my problem that my x went from -4 to 4? So I know my limits of integration are from -4 to 4. So now I just need my radius. What is my radius of my disk? No matter where I put it, doesn't it always correspond to my function? So my function is the 1 minus x squared over 16 squared, pi r squared. Right? That was pretty easy. You can now do that in the calculator if you want to. You could do it by hand if you want to. If you do it by hand to practice, you should get 64 pi over 15. If you do it in the calculator, you should get 13.404. Because this is a word problem and they give you dimensions, you need to make sure that you add dimensions on. The 13.404 represents what? It represents the volume of that pontoon. When we do volume, volume is in what units? Well, in this case, they labeled it feet, but it's feet what? volume should be in feet cubed. Okay, so this would be our volume of our pontoon. Okay, that's for disk method. What if we tried to do the same problem, but this time with shell method? Okay, we're doing the same axis of revolution. If my x-axis is my axis of revolution and I want to do the shell method, then my rectangles are now going to go horizontal. They're going to be parallel to my x-axis. So my rectangles are now going to be horizontal. In order to do the shell method, right? In order to do the shell method, I've got to do my 2 pi p h w. I've got my 2 pi, that's easy enough. Because they're sideways, because they're horizontal, aren't I integrating now then with respect to y? Okay, this is the tricky part with the shell method on this problem anyway, is if you look at that picture, isn't that just half of your pontoon boat, right? So if I integrate it the way it is right now, and I integrate it from 0 to 2, you wouldn't have that pontoon anymore, right? Not a pontoon boat, just a pontoon. Oops, I put 3, but I meant 2. No, I meant 1. Sorry, I apologize. From 0 to 1. If I went from 0 to 1, it would only be half of my pontoon. So if I find the volume, and I keep it the way it is, and I integrate it from 0 to 1, what would I then have to do with my answer? Can I just double it, multiply it by 2, since it should be symmetric around the x-axis? If I rotate it, I should be able to take this volume and just multiply it by 2 to get the other part of my pontoon, okay? But then I need my p, right? I need my p. So I've got to figure out what the p is. Remember, the p is the distance from my axis of revolution up to my rectangle. So what is it from the x-axis up? Well, it's really the y distance, right? Y. Now I've got to figure out what my height is, okay? My height is the distance between these 2 points. But because my rectangle is sideways now, because it's horizontal, I can't do it from the y equals graph. I need a what? I need an x equals graph. So if your original equation was y equals 1 minus x squared over 16, how would you get x by itself? You could subtract the 1 over, right? Then could I multiply everything by -1 just so that I would get this x squared to be positive on that side? So I'd have a -y plus 1 equals x squared over 16. Then what would I have to do? I'd have to multiply both sides by 16. Then I would have to square root, right? I'd have a whole bunch of algebra, extra algebra stuff that I'd have to do in order to be able to get me to my height of my rectangle. Wasn't it much easier just to do the disk method on that one? Okay, so sometimes disk method is easier, sometimes shell method is easier. Sometimes you can only do one or the other because it doesn't work otherwise. Okay, as you're walking through your homework tonight, kind of visualize what they would both look like. What would it look like if you did disk? What would it look like if you did shell? You might see a pattern on when it might be easier to use one over the other. On your test, I'm not going to specify what you need to use, so you can use whatever you'd like, but make sure you use the right one. All right, hope that helps, guys. I'll see you on Thursday.